Good day. I am Lloyd M. Donaire with my partner Steven John Paruco of BSEE 3A. This video contains discussion of the construction of DC machines and the principal operation of DC generators. But first, let's define what DC machine. DC machine is an electromechanical energy conversion device. DC machine means both DC motor and DC generators because constructionally both are similar. It's just in DC generator, it converts mechanical power to electrical power, and in DC motor, it converts electrical power to mechanical power. Now, let us discuss the construction of DC machines. First of the essential part is the yoke or the magnetic frame. It is cylindrical in form, and its main purpose is to be a protecting cover from its environment and mechanical supports to the poles. It also carries the magnetic flux from the poles. In small generators, yokes are made of cast iron considering the financial budget, but for large machines it's usually steel or rolled steel. Terminal backs, lift eye, feet are welded to the frame because it has sufficient mechanical strength and high permeability to support it. But that's all in the exterior of the yoke. But inside, poles are attached. Poles are welded or joined with the help of bolts. Is usually circular section, and cores are usually not laminated. They carry field winding and pole shoes. Pole shoes serve two main purposes. They support the field coils and spread out the flux in air gap. Because it is large in cross section, it reduces reluctance of the magnetic path. Pole shoes are always laminated to avoid overheating and eddy current losses. So these are the pole cores and this is the pole shoes. The other part is field winding. It is usually copper, and field coils are wounded and placed on each poles in series connection. They are wounded in that way, so when energized, they form these alternate north and south poles. Next is armature core. Armature core is the rotor of DC machines. It is cylindrical in shape and includes a huge number of slots within its edge. The armature winding, or also called armature conductors, is located in these slots. The armature core is made of thin lamination silicon steel, and each lamination is insulated to each other by thin paper or thin coating of varnish to avoid eddy current or locking. Armature winding is found on the slots of the armature core. They are made up of copper and insulated from each other and insulated from the armature core. Armature winding can be wound by one of the two methods. It is the lap winding or the wave winding. Next is the commutator. In DC generator, the function of commutator is to collect the current generated in the armature conductors, wherein motor commutator helps and provide current to the armature conductors. So in generator, it collects, and in motor, it provides. A commutator consists of a set of copper segments and which are insulated from each other. Each segment requires a armature coil, so the number of segments and the number of armature coils are equal, and they are connected to each other. Brushes are usually made from carbon or graphite. They rest on the commutator segments and slide on the segments when the commutator rotates. This is how the brushes are used to carry current from the armature conductors. The shaft use transfer mechanical power. So if the machine is a DC motor, mechanical power is transferred from motor to load. And if it is in generator, mechanical power is transferred from prime mover to a machine.
Good day everyone, my name is Steven Jan Faruco and with my partner Lloyd Donaire. My report is all about principle of operation of DC generator. So before that, what is the two types of generator? There are two fundamental types of generator known as AC or alternating current and a DC, a direct current generators. While the technique of producing electricity is the same in both types, AC and DC power become different in terms of their application, the way in which loads receive electric power. What is DC generator? Electrical generator, mechanical gen energy generator to electrical energy, stationary magnets, rotating magnets, and electromagnets. So a DC generator is an electrical machine whose main function is to convert mechanical energy into electricity. When the conductor slashes magnetic flux, an EMF will be generated based on the electromagnetic induction principle of Faraday's law. Generator principle. This explains a principle of operation of a DC generator. This have conductor, magnetic field with a single loop DC generator. The energy conversion in a generator from mechanical energy to electrical energy is based on the principle of the production of dynamically induced electromotive force or EMF. Whenever a conductor cuts magnetic flux, dynamically induced EMF is produced in it, according to Faraday's law of electromagnetic induction. This EMF causes current to flow if the conductor circuit is closed. Hence, the two basic essential parts of an electrical generator are A. A magnetic field and B. A conductor or conductors which can so move as to cut the flux. So, how a DC generator operates? A DC generator operates on the principle of electromagnetic induction. When the magnetic flux linking a conductor changes, an EMF is induced in the conductor. A DC generator has a field winding and armature winding. So how does a DC generator produce DC? DC generator and the types of DC generator with a brush, armature, sealed ball bearing, shaft, frame or yoke, pole shoe, field windings, and commutator. So a direct current DC generator works on the principle that a voltage is induced in the conductor coil when it is rotated in a magnetic field. The rate at which the coil rotates in the magnetic field determines the amount of voltage induced in the coil. So, simple loop DC generator. A single turn rectangular copper coil ABCD rotating about its own axis in a magnetic field provided by either permanent magnet is or electromagnets. The two ends of the coil are joined to two slip rings A and B, which are insulated from each other and from the central shaft. A simple DC generator consists of a coil of wire rotating in a magnetic field. However, it is used as split ring commutator rather than the two slip rings found in alternating current AC generators. So some bike slides use a type of DC generator called a dynamo to run the laps while the wheels are turning. And that's all. Thank you.